You carry on, Craig. Oh, is it my go? Hi there and welcome to this month's edition of In the Labs with me, Becky. And this month I'm going to show you how to create your very own garden 4 in a row. So let's take a look at the build. So let's go and open an existing file. I'm going to take the connect4.crv file. So this file can be opened in Cut 2D, VCarve and Aspire. So the first layer that you're going to see is called Parts in View, and I've basically created this so we can talk about how everything is going to slot together. We've got a layer here called Sheet to Cut, so these are the actual parts that I'm cutting out on the CNC, all laid out like so. And then I have another layer here called Counters. I'm cutting the counters out of a different material, so this is just here for you guys so you can see the counters separately to everything else. Okay, so let's have a look at the Parts in View and we'll talk about how everything's going to come together. So we'll start by looking at the main grid interface. So with the grid, it's basically a rectangular shape that has 7 columns of holes and 6 rows of holes. And the idea is you drop those counters down to reveal the colours in those holes that we're going to cut out in our grid. So 3 important things to talk about here are the 2 circles and the rectangle shape. So what do they represent? So we have the smaller circle that represents the holes we're going to cut into the panel. The larger circle represents the actual counter itself when it's dropped down the actual grid itself. And then we have this rectangle that's going to represent the track in which the counter is to fall down. So we're going to be cutting 2 grids in total that are going to come together, and the tracks are going to be created using the pocket toolpath, where we're going to cut down at a depth on both of the grids to create an area for us to drop the counter down. Okay, so it's going to look something similar to this. So this is our one grid, what you saw over here, and we have another grid. So remember, we're looking down on the top view here, and so the idea is we're going to have a hole that would look something like this, which is based on 2 pocketed areas coming together, and then our counter is going to drop down. So I'm going to make sure that my pocket toolpath is going to be a little bit deeper than half of the material that I plan to use, just to make sure that we have some room for our counter to fall down. I don't want to create the exact depth of cut of half of my counter thickness, otherwise that counter isn't going to fall nicely down. It's going to get stuck somewhere, so you want to give that a little bit of room for movement, but not too much that we could get 2 counters in side by side to fall down the track at the same time. So my counters that I'm going to cut them out of acrylic. It's 0.1 of an inch thick, so I'm going to make sure that my pockets on either side are somewhere around 0.065 that we're actually cutting down at, and that's just going to give me a little bit of room for play for the counter to actually drop down without getting stuck. Talking about the counter getting stuck, I'm going to make sure that my track is a little bit wider than the counter as well. Again, all about making sure that that counter is not going to get stuck anywhere. It's going to drop down, but we're not going to mess up the pattern either. So I'm just giving it a little bit of forgiveness on the left and the right there. So what's going to stop the counters from falling out at the bottom? So I'm going to create a tray. It's basically just a piece of material. It's just a little bit wider than the actual grid itself. And that's going to slot into a mechanism that's going to pivot, that we can kind of move out the way to release those counters and then move it back in position, so that the counters can stack on top of each other. And you'll see that in my vector drawing I've got our counter at the bottom here, and we can see that with the size of the counters we're cutting, everything that's going to stack on top of each other nicely. And we'll come back to this tray pivot mechanism in a second. Right then, so the grid itself, that's pretty much it. I've created these arms that come out either side of the grid, and these arms are going to connect to our side panels. So let's take a look at the side panels. So I'm just going to take these temporarily, and I'm just going to cut them for the time being. Right, and so the idea is this arm is going to slot into this hole here, this arm is going to slot into this hole here, and we're going to have another panel on the right hand side where those same arms are going to slot into those same holes. The actual side panel itself is going to have a foot, so this part is going to slot into this area here just to make it a little bit more stable. So the slot that we've got on the side panels has a thickness of 2 lots of grids. Okay, so the 2 grids will slot into here, and then over here the distance between the sort of end of the hook end of the arm and the actual grid itself is a little bit wider than 2 lots of thicknesses of the material you're using. 1 for the actual side panel and 2 for this part here. So this is our pivot mechanism that's going to release and hold those counters in place. So talking about this, let's have a look how this is going to work. Okay, so the idea is that we're going to have this piece as a standalone part. And this is basically a hole, and this hole is also going to be cut into this side panel exactly as we see it here. And then we're going to insert a dowel to enable us to pivot this part. At the bottom here we've got a slot for the actual tray to go into. Now this rectangle actually represents the thickness of that tray, and you can see that I've done it I've done the actual slot a little bit bigger, just to allow for some room for movement, just to make sure it goes in there. I've got to bear in mind that I am painting this as well, so I made that a little bit bigger there. And so the idea is that if I paste those 2 vectors back in, so these vectors represent the actual grid, the 2 grids that come together, as if we're looking at it side on. And then if I take this part along with the circle or the dowel area, just going to select them all again to put it into transform mode, select the center point. If I click on that, you'll see it's turned into a target. This is my rotational center, so I'm going to snap that to the center of the circle, which is actually our dowel, and this is our pivot point. And so I can see that if I rotate this, this is exactly how it will move, and we can see that that slot isn't touching our grid at all. So I know that it's not going to be in the way. We should have a nice smooth movement underneath there in order for us to be able to release those counters from the grid. So as this is a slot together pie, you want to make sure you include your fillets everywhere where parts are going to be slotting into other parts. Now the fillets I've used, it has a radius of 0.125, so 1/8 of an inch, and that's because I'm using a 1/4 inch end mill to cut this profile out. And looking at this part here, so the distance between the arm and the actual grid, I've done that based on the thickness of the side panel that it's going to slot into and the thickness of this pivot part. So we've got two lots of thicknesses there, and I've just made it a little bit extra just to account for the part being able to pivot, so it's just a little bit wider there. Right then, so that's pretty much it. So let's go to the sheet to cut. So I've basically got the grid. We only need the holes, we don't need the counters in our sheet to cut. We're going to cut those counters separately. And I basically took one of those and then copied it horizontally to create the other side. And then we have all of our different parts. We've got our two side panels, our 2 feet, and our 2 pivot parts, along with a single tray. Okay, now that tray is going to slot into this hole and this hole here. So I've made it a little bit bigger than the actual grid itself, so that everything sort of forms in unity. Right then, so those are all the parts. So let's take a look at the toolpaths. Okay, so we're going to start by looking at the track. So here I'm actually using a 1 1/4 inch end mill, and we're just basically just doing a raster cut there, and you can see it's cut that out at a depth of 0.065. Okay, so you want to change this according to the thickness of the material that you plan to use for your counter. So just make it just a little bit more than half of the thickness of the counter you're going to cut. Right then, so if we tile our windows, take a look at the next toolpath. So then we've got a profile toolpath, just cutting out the circles on the inside, just using a 1/4 inch end mill, like so. Then we've got our profile cutouts, that's basically profiling all of our parts, like you can see here, and if we preview that, again we are using a 1/4 inch end mill to cut those out. Then I have another toolpath here called Profile Slot Holes with an allowance using a 1/4 inch end mill. So I'm looking at all of the slot holes and the dowel holes. So that's all of these pink highlighted areas that you can see here. Now, as this is a slot together project, you want to make sure that we do a little bit of an overcut to ensure that our parts slot together nicely. It's not too tight, it's not too loose. That's why I've created this toolpath separately, just to apply the allowance on there, which I've gone with negative 0.01, so that when we actually see that toolpath, if we go ahead and just switch on the visibility there, I zoom in, you can see it's just going a little bit past the actual vector itself, creating that allowance. Okay, so make sure, as with all slot together projects, you do test cuts first to find out the best overcut to create a nice fit. Okay, so make sure you do that. So I've already done that, and 0.01 works for me, so we'll go ahead and preview that one. And then the final toolpath is profile overcut slots. So what are we looking at here? So that's basically the slots for the side panels where the feet are going to slot into. Okay, now I've literally just specified it on this area, so I've drew a vector that represents the slot and just manually overcut that by using the offset tool. We've offset that outwards by 0.01. Why have I done this separately? Because I didn't want to basically overcut the entire thing. I only wanted to overcut the actual slot parts, not the overall profile of the part. That's why that's separate. So then we could go ahead and preview that, and then this pretty much is all of our parts. So at this stage you could go ahead and save those toolpaths and start
running those on your CNC. Now, if you wanted to create a smaller version of this, you can do, by all means. Just take the design and shrink it down, but bearing in mind all of the thicknesses of your slots, the arms, the depths of cut that you're going to be pocketing down, the tracks, the circle holes, but you've pretty much got a design here that you can work with and edit. Right then, so we're going to go and save those toolpaths out and head over to the labs.
Okay, so now that we've got our files, I've got my sheet of MDF, I've covered it in double-sided carpet tape, stuck it onto the machine bed so we've got maximum hold down there, and all I have to do now is set up the machine and then run those toolpaths. Okay, so I've got my dowel. I've measured out the thickness of 2 of my MDF pieces. I've marked it, so all I need to do is just basically cut that out. Cool, so we've got one, and now I just need to do another one.
So for the counters, I'm using 0.1 inch thick Perspex sheets, and I'm actually just going to laser those out. So with everything cleaned up, when I put the 2 panels together, I have a little bit of a bow in both panels, so I'm going to have to look at gluing the parts together.
Okay, so now the glue is dried, everything is pulled together, we don't have that bow that we saw earlier. So I've cut a test counter out, so we could drop that in, see how it works, perfect. So all we need to do now is look at spraying this with some primer to begin with, and then we'll go over that in the classic Connect 4 blue colour. Okay, so the paint is dry. We've got quite a nice glossy effect there. It's come out a lot better than I expected it to, so I'm pleased with that. So these are all the parts for the side panels and the bottom counter tray. So the idea here is that we're going to take this part here along with the dowel. That dowel's going to go into here, and then that is going to go into this hole there. And then in this slot here, we're going to take the counter tray, and that's simply going to slot in there so that we can then pivot that to release the counters. So I'm going to start assembling all of that together. So let's take a look at that. Okay, so assembled everything together. Hasn't quite worked, so I'm just going to talk you through some of the things that I need to change. Right then, firstly, the tray at the bottom, the more counters you put in, the more it actually bows at the bottom. So what I'm going to do is I'm going to look at taking another piece, and rather have it this way down. I'm actually going to turn it 90 degrees so that the counters land on this side. This side is not going to bow, but it's enough thickness to keep the counters in place as well. So I need to change the slot hole on our swingy parts here. When I come to release our counters, you can see exactly what's going on here. I haven't got enough room between the bottom panel of the grid and the floor for the counters to be released freely. Also on the left hand side and the right hand side, you can see that the legs of the side panels are actually in the way for us to release that as well. So I'm going to look at maybe making the legs a little bit longer so that we're raising the whole thing up. And then a final thing is that where I'm slotting the main grid into the side panels, I have a little bit of flex here. And the reason for that is at the bottom you'll notice and you'll remember that we have this pivot tray as part of that thickness for when we're creating these arms, but we don't have it at the top here. So I'm going to look at creating some kind of a wedge that's just going to sit in this part here, just to keep that well away so it's not coming in like you can see there. So I'm going to go and get on with changing the pivot parts for this and the legs on the side panels. We'll recut those and then we'll come back and reassemble everything and see how that works.
Okay, so here's the file. Made edits to accommodate all of the flaws that I discovered when assembling everything. So the side panel made longer. So this is it stood on the floor, and this is where the grid would be in line with the side panel. So I can see here that a counter is going to fall out perfectly there. It's not going to get stuck like we saw just. So having said about rotating the tray 90 degrees so that it can handle the weight of all of the counters, I've rotated the slot 90 degrees. I've had to make this part longer just to accommodate that rotation. And as we saw in the software before, I want to just make sure that that rotation center is in the center of our dowel. So this is our pivot point, so when I rotate that, I can see it's not actually going to be in the way of the bottom of the grid. The leg, I've basically just cut off the right hand side so that that doesn't get in the way of the end columns when the counters drop down. You could argue that you needn't even have this part and this could just stand on its own, but for good measure I'm just going to put that in there for stability. And then we've got a peg here that's going to sit on top of this arm here just to keep the whole thing rigid. Now I've put all the parts in the sheet to cut, so this would be the correct file. I've recalculated the toolpaths for you so you can run those. So I'm going to go run the new parts that I need and we'll catch up shortly. So before I do that, I'm just going to go and save this file out. I'm just going to call this one Garden 4 in a row and you can access that from your portal account.
Okay, so I've made the changes and I've recut the parts that I need to, so everything works perfectly. So let's have a look at what we've changed. So I've added in the pegs on either side of the grid. It's more rigid, that is not moving anymore, so that works perfectly. Coming down to the bottom, I've removed the feet on either side of the grid. That way when the counter drops down, it's not going to hit that foot, it's going to fall freely. Talking of the counters falling, before we saw the counter tray was very bowed with the weight of those counters. Now that we've rotated that 90 degrees, you can see it's not bowing. And then finally, when I release those counters, because I've raised everything up, those counters are falling as they should. They're not getting stuck to the floor. So everything works perfectly there. So So if you fancy having a go at creating your own version of the garden 4 in a row, then head over to your VCarve account where you can download the project files from there. And if you like this video, give us a thumbs up, and if you've not yet subscribed to our channel, then please hit subscribe to get instant updates on the latest videos that we're releasing. So thank you for watching and happy making!